All right, so just in case you may have missed the rules from last class, here are your exponential rules. We only went through two of them last class, the first one and the second one. When you have your same base, you're multiplying, you add your exponents, you have your same base and you're dividing, you subtract your exponents. And we're going to look at these next 8. All right. So, anybody need me to hold off? Anybody didn't get them from last class? Everybody's good. Everybody good.
Hey, Professor, I got a good question
Yep.
about the test. How we supposed to take it?
You contact Mr. Davis. It's JL at tcc.edu. That's JL Davis at tcc.edu. And he will set up a time for you, discussing with you your schedule as far as through Zoom and everything. They'll proctor
And also, on it's like the review one above it. It says it needs a pass. I need a password to do the review.
for the test for the review.
Yeah,
Okay, I'll check that. I should have taken that off. But if a password, yeah, I'll remove that.
I tried emailing you yesterday, but I don't know if it went through or not or anything.
Yeah, I didn't see one from you. But okay, I'll take a look at that.
Wait, Professor,
Yes.
when's the test again?
You do it as soon as you can. I haven't put a date on it. But as soon as you get through covering your homework in chapter, what is it, 4 and 5, then you want to take it as soon as possible so you can go and get out of that section and get into chapter 6.
Oh,
Okay.
okay, sweet, sweet. Thank you.
Yep, no problem. So just in case anyone else, may have not heard when I was discussing the test, we're not doing the test as a class. You would do it on your own time. You will set up a time for yourself individually to go in with Mr. Davis in the tutoring center or the testing center. So now this testing center is different than the school's testing center. So this is just, this tutoring center just only do, I think, math and a few maybe reading or English or something like that. So this is not the general testing center. So don't go to the general testing center in order to take your test. You contact Mr. Davis at jldavis at tcc.edu, and he will set up this. So the testing center, the general testing center, is not where you go to take these tests. You will go through Mr. Davis. All right. So let's go ahead and do some more of these exponents. So I think the third rule that we discussed. And let's see, this is and I think I actually, let me go back to the rules that I gave you. I think this is the one I made a mistake and put at the bottom. Yeah, I made a mistake put that one as 10, but really I should have done it earlier. So in your review, so we'll just call it 3 right now, but it's all good. All right, so whenever you're raising a power to another power, you're going to multiply your exponents. So if I have s to the 4th raised to the 2nd power, that is 4 times 2, and that'll be s to the 8th. So power to a power, you multiply your exponent. So that means this would be 3 to the 50th power. 10 times 5, And here we have x squared times x to the fifth raised to the fourth power. First thing you would do is go ahead and simplify what's in your parentheses. And don't forget, whenever you multiplying terms with like bases, you're going to add your exponents. So that'll be x to the seventh. And now x to the seventh raised to the fourth power, x to the 28th. All right, next one. If I have different bases, then I will apply my exponent to each one of them individually. So if I have xy raised to the nth power, that's x to the n, y to the n. So this 4 is going to hit each term that's in the parentheses individually. So that's negative 2 to the fourth, x to the fourth, y to the fourth, and z to the fourth. Negative 2 to the fourth is negative 2 times itself 4 times. So it's going to be a positive 16. And the other one is just x to the fourth, y to the fourth, z to the fourth. All right, next one, 5x squared, y to the seventh raised to the third power. There's 5 cubed, x to the second cubed, y to the seventh cubed. So 5 cubed is 125. Don't forget a power to a power. Just finished talking about how you multiply your exponents. Same thing here. Y to the 21st. All right, any questions? Any questions? So same thing happens when you have division involved. You have x over y raised to the m power. I'm going to apply the m power to each term individually. Or I guess I should say, well, yeah, each term individually, whether it's all numerator, denominator, or what. So we got 2 to the fifth, third power. All right, so 2 over 5 raised to the third power. That 3 needs to be applied to the numerator and denominator. So that's 2 cubed over 5 cubed. 2 times 2 times 2 is 8. 5 times 5 times 5 is 125. Here we have 2x cubed over y to the 5th squared. So the square needs to touch all 3 pieces. Two squared is 4. Power to a power, you multiply, so that's going to be x to the 6th, and then y to the 10th. All right. Questions? Any questions? Let's do a few more simplifying before we go to our negative exponents. And these are not, the ones I'm about to use now aren't based on any one rule, but just making sure you know how to use all of the rules as they come to you. So we want to simplify this as much as possible. Directions would be just simplify the expression. It's not going to tell you by using this rule or that rule. So when I see, once again, power raised to a power, then I will multiply those exponents. So that's x to the 12th. And on bottom, x to the 14th. Now, when you have your multiplication of like bases, then you go ahead and add your exponents. So that's what's going on right here. So that's x to the 15th over x to the 14th. And then when you divide, you're going to subtract your exponents. X to the first power x to the first power, and anything to the first power is itself. So to write that as simple as possible, it would just be x. Questions? Any questions? Also notice the difference between this and the last one that we did. The last one had x and y. We had x to the 6th over y to the 10th. You can't simplify that. Those are two different variables. This one had all x's, so we were able to subtract our variables, add our variables, and all the good stuff like that. So if you have different variables, you can't do anything with this. But if all the variables are the same, then you can keep reducing until you only have one variable left, as long as you follow your exponent rules. All right, so let's do at least one more before we go on to another rule. All right, so we got 3CD squared times 2CD cubed. All right, so this cube needs to be applied to each term. And so at first parentheses, those terms will stay the same. Then here we're looking at 2 cubed, C cubed, D cubed, cubed. So I'll leave it like that. Two cubed is 8. C cubed is C cubed. Once again, a power to a power. Multiply your exponents. So now we will, even if you don't write this step out, the way you will process this is you would look at 3 times 8, C times C cubed, D squared times D to the 9th. All right. 3 times 8 is 24. Here, adding your exponents, that's C to the 4th. So don't forget, when you don't see anything, just like we just mentioned, there's a 1 there. And then you have D to the 11th. All right, questions. So we already talked about what it means to be have 1 as your exponent. Remember I said that's, itself. So if I have 5 to the first power, that's just 5. But when you talk about having a 0 as your exponent, anything to the 0 power is 1. So anything to the 0 power is 1. So 4 to the 0 power is 1. X to the 0 power is 1. Negative 4 with parentheses to the 0 power is 1. Remember what we talked about, thought we talked about in this class, but if not, we're talking about it now. When you don't use parentheses versus when you do use parentheses. If you use the parentheses, then it's going to incorporate everything that's in the parentheses. If you do not, it is only applied to what it is right up against. So when I look at this next one, the 4 is being raised to the 0 power, not the negative. So that's actually negative 1. That negative is still the same negative that's sitting out front. It's just that it was not affected by the 0 as an exponent. Once again, if you want it to be affected by the 0, then you need these parentheses. Same thing happens over here at -4 x to the 0 power. What's being affected by the 0 power is the x, not the -4. So what happens here is that's going to be -4. And x to the 0 power is 1. So the result would just be -4. And then here 4x raised to the 0 power is 1 because everything in the exponent, everything in the parentheses is affected by the 0 power. All right. Questions about the 0 exponent? All right.
Professor,
Yes, sir.
can you move us? It's like whenever you write to the other side of the screen, we can't see the other part of your notes.
What you mean? Left, right, up, down? What you talking about?
When we, like on my screen, I see you, Jonathan, but when you write, it goes underneath the people. So we can't see the rest of the equations or the exponent.
So, okay, let me ask you this because I don't know what y'all seeing because, if I'm writing, that means I can see it. You know what I mean? So I'm trying to get a gauge as to what you mean you can see. So now
Like I
moving
can't,
this.
like I can't see beyond X, Y.
You just have to memorize it on your string, not the professor.
Oh, okay.
Okay,
Yes.
cool. All
Oh,
right.
thank you.
Yeah, thank you because I was like, All right.
Oh, whoever said that, tell them I said thank you.
Yeah, I believe she can hear you. Cause I don't know who said it either. Was that Miss Chambers who said that? I'm not sure. All right. So negative exponents. If you have a negative exponent in your numerator and you want to make it positive, you can drop it down into your denominator. And then if you have a negative exponent in your denominator, in order to make it positive, you can bring it up to your numerator. And then in that third relationship, if you have a negative exponent being applied to a fraction, if you apply the negative, then that flips the fraction. And basically that's just a reflection of these two, relationships. So when I look at this c to the negative third power, because when it comes down to it, writing a fraction in the simplest form, not writing a fraction, writing the exponent or expressing the exponent in its simplest form, They 9 times out of 10 do not want a negative exponent. So if I have c to the negative third power, then to make it positive, I just bring it down bottom. There was nothing else left, so that's why I would just have 1 in the numerator. And you'll see what I mean when I bring up another example. 5 to the negative first power, drop it down bottom. It's just 1 over 5. Negative 3 to the negative fourth power, drop it down bottom. And that's 1 over negative 3 to the fourth power now. But you can simplify that. Remember, I told you that's one of those ones where if it's small enough, the exponent is small enough, they are expecting you to go ahead and simplify that. So if it was negative 3 to the 41st power, then they wouldn't expect you to do it. But negative 3 to the fourth power is just negative 3 times itself 4 times. And that will give you a positive 81. All right. Questions? Any questions so far? Yeah. All right, so if I have 1 over x to the negative fifth power, to make it positive, I bring it up to the numerator. All right, here, parentheses says that the negative 7 is applied to each term. So I bring both of them down bottom. That's now a positive 7. Now I can apply the 7 to each. All right. So the next one, be careful. There are not any parentheses involved. So that negative 7 as an exponent is only applied to the y. So the x stays in your numerator. The y drop down to your denominator with the positive 7. Then this next one, b is only affected by the negative 8. So the b is brought up top and the a stay down bottom. All right. Questions on the exchange of negative exponents or the transferring of negative exponents to a positive exponent? All right, so the next one, we have 1 over 6 raised to the negative second power. So remember that last relationship was if you have a fraction raised to a negative, if you apply the negative to the fraction, that flips it. So that 1 over 6 raised to the negative second power flips to 6 over 1 raised to the positive second power now. And we know that 6 over 1 is just 6. So that'll be 36. Once again, when it comes to these exponent rules, it's not going to be about, well, the easiest way to attack them is not to try to memorize them, but it's about you taking the time out, getting your repetition in, and you are using these rules versus trying to memorize these rules. All right. Next one, we got negative 3/5 raised to the negative third power. So these two negatives have nothing to do with each other. So don't automatically go negative to a negative is positive and all the good stuff like that. These two negatives, are applied in their own little stratosphere, their own little world. So those negatives have nothing to do with each other. So this negative as an exponent, just like we've just finished doing in the last example, is going to flip the fraction, but the fraction will still be negative. So once again, those two negatives have nothing to do with each other. And now I can apply the cube to each, to the both top and bottom. So that's negative 5 cubed over 3 cubed. So that'd be a negative 125 over 27. All right, so this next one, we have x squared times x to the negative 7th power over x cubed. First thing I would do is go ahead and add my exponents up top because I'm multiplying. So 2 plus negative 7 is negative 5. And here, be careful. I'm dividing, so I'm subtracting my exponents. So it's negative 5 minus 3. And that's actually going to be x to the negative 8th. And there are different ways. I'm not finished because, well, let me say this. Let me go ahead and finish it. And then they're more than likely they're going to write you to expect you to write it as a positive exponent. So to finish it off, you drop it down bottom to make it positive. So it's 1 over x to the 8th. So there are many ways of doing these. If I wanted, I could have brought this x to the 7th, negative 7 down bottom first, and then worked it out that way. Could have subtracted 3 from either one of my exponents first. Different ways you can play around with it. But bottom line, you still should get 1 over x to the 8th as your final answer. As long as you apply the exponent rules, you will be good to go. All right. So the next one, if you want to break it up for as far as looking at just my W's and just looking at my Z's. So I have Z squared over W to the negative fourth power times W to the fourth over Z to the negative eighth. So I could look at it this way. So that's the only way I can simplify, is that I simplify my W's, simplify my Z's separately, then bring them together with whatever the result is. So down bottom at my W's, I can, since they're being multiplied, I can add those together. I'll do it like this. That's going to be W to the 0 power, because we're adding negative 4 plus 4 as an exponent. So remember, no matter whether you're multiplying in the numerator or you're multiplying in the denominator, if you are multiplying, then you add your exponents. And the next one, I'm doing Z squared minus negative 8. So be careful there. Division says subtract, but you're subtracting a negative 8. So make sure you don't lose a negative. W to the 0 power is 1. And that's going to be Z to the 10th power. So it's negative 2, not negative 2, 2 plus 8. So my final answer is Z to the 10th power. Questions? Any questions? I just pulled up another screen. That's not blocking you guys and what you can see, is it?
No.
All right, great. I just want to see if there's anything else I'm missing as far as exponent rules, simplify the expression. We can do this one. Where's my phone? All right, so we'll do a couple more. Just pull a couple more from your homework. All right, so we have 6a to the 5th b squared, negative 42 a to the 7th b squared. I'm gonna change that. I'm gonna change the top b squared to b to the 11th. So 6a 5th b to the 11th, negative 42 a 7 b squared. So we had one similar in setup to this one already, wherein I say you will break up the common pieces. Like I said, even if you don't write this out, this is how you would process it. You would be looking at the 6 and the 42, the A terms and the B terms as far as how you would simplify. Now the 6 over the negative 42, that 42 is 6 times 7. So those 6's can cancel, and that's going to be negative 1 over 7. Well, your 6's cancel out. A is 5 minus 7. B is going to be 11 minus 2 for your exponents. All right, so that's negative 1/7, A to the negative second power, B to the ninth. So to write it with positive exponents and to write the fraction all together, the A drops down to your denominator with the 7, the B stays in your numerator. And so this is how it will look. All right, so the next one, 20c to the 7th, d to the 6th, or 5c to the 19th, d squared. So we can handle this one of two ways. You can apply the negative exponent to each term and then simplify further, or you can simplify what's in the parentheses first and apply the negative exponent on the outside last. I think that's what I would do. I would go ahead and simplify what's on the inside of the parentheses first, and then come back to the exponent on the outside. But to each his own. Either way, if you stay correct with your exponent rules, still get the same result. So what I would do is go ahead and do 20 divided by 5, which is 4. C to the 7th divided by C to the 9th. So that's going to be C minus 19, 7 minus 19 for your exponent. Then for D, it's going to be 6 minus 2 for your exponent. So that's 4. C to the negative 12. D to the 4th. All right, so you can drop that C to the 12th down bottom in order to make it a positive exponent. And that's what we're looking at, 4D to the 4th. over c to the 12th raised to the negative third exponent. All right. So now if I want to apply that negative to the fraction, that's going to flip the fraction. So that's c to the 12th, 4d to the 4th. And now I can apply the cube to each piece. C to the 12th cubed, 4 cubed, d to the 4th cubed. All right, exponent to an exponent means you multiply, so that's c to the 36th power. 4 to the third power is 4 times 4 times 4, which is 64. And then that'll be d to the 12th. Questions? Any questions? Let's see. So let me go here. Okay. Trying to see if there's any difference. I'm looking at the next section. Oh, okay, talking about degrees of polynomials. Okay, so we got a few minutes left, and your next section is very short. It's only 7 problems dealing with some terminology of polynomials. So I'm gonna go ahead and give that to you. As a matter of fact, let me see if I can share the screen. All right, so hopefully you guys can see my Connect Math McGraw-Hill. Says a single term, sum of terms. All right, so a single term or a sum of terms is polynomial. Okay, so we're talking about polynomials in this section. Notice that you only have 7 questions. And so we're talking about polynomials, and I'm going to go back to the notes, but I'm just showing you what it's asking of you. We just did that, you know, for some reason they threw this in here with exponents. So here we're talking about, and that's once again talking about exponents, the difference between 5 times 10 to the 8th and 5 to the 8th, where you know the exponent is only being applied to the 10 and one exponent is being applied to the 5 and the other. So you guys can go and, you know, it's not. So I try not to give you that answer because it's only one of, you know, it's only one of two answers. So you guys can do that one. But here, so we need to talk about polynomials, what it means to be in descending order, leading coefficient, and all the good stuff like that. And like I said, there's only 7 problems. So just showing you what they talk about: binomial, monomial, trinomial. So let's go back to the notes. So just in case somebody wanted to move ahead, polynomials. So polynomials, I'm pretty sure there's a better definition than this one, but it's good enough. Just an expression that has variables, operations, exponents, etc. So an example of that is x plus 5. 15x squared is a polynomial, and all of these are individual examples. And it stand alone as a polynomial. 3x cubed plus 7x minus 9. So when you talk about your terms are separated by the plus and minus signs. So if I look at 3x cubed plus 7x minus 9, the terms of this expression is 3x cubed, 7x, and the negative 9. So those are your 3 terms. Terms are separated by your plus and minus signs. No, I want to go coefficient first. So your coefficient is just a number that's in front of the variable. So if I go back to 3x cubed plus 7x minus 9, your coefficients will be 3, 7, and negative 9. Or let me write it like this. Coefficient of 3x to the third power is 3. Coefficient of 7x is 7. Coefficient of negative 9 is negative 9. All right, so the degree of a term is just the exponent on the variable. So 3x to the third power, the exponent on the variable is 3, 7x, exponent is 1, and then -9, the exponent is 0. If you don't see a variable at all, your exponent is 0. All right, so make sure when they start talking about degrees that you pay attention to the term or to the idea of already talking about the degree of the term or the degree of the polynomial. Degree of the term, you have your individual terms that are in your polynomial. The degree of the polynomial is going to be the largest exponent in the polynomial. So going back to 3x cubed plus 7x minus 9, the degree of the polynomial is 3, because that's the largest exponent in your polynomial. So like I mentioned, this section is pretty much just terminology. So your constant is the number that is not attached to the variable. That's just the -9. That is good. Let's do descending first. All right, so descending order is arranging your terms from largest to smallest according to your exponents. So we're not looking at the numbers in front. We're not looking at your coefficients. We're looking at your exponents. So they ask you to rearrange your terms in descending order. Then you're looking at your exponents. So we have x to the 7th, x to the 6th, x cubed, x to the first power, then no x at all. And then ascending order. So ascending order is just the opposite, arranging your terms from smallest to largest according to your exponents. And I didn't put this up here for the first one. This is the one that's normally used. Normally we go from from largest to smallest. Normally we use descending order, but you never know. As an exercise, they may ask you to write it in ascending order. So if I take those same terms, so yeah, notice my 8 is still negative. Everything is, whatever was negative is still negative. Everything that was positive is still positive. All right, questions before we close it out? All right, so a monomial is one term. So mono is your prefix that signifies one. Binomial, bi, two terms. So we have 7x for the monomial as an example. Binomial, 7x minus 5. Trinomial, 3 terms. So trinomial, 3. And then just a regular polynomial. Poly means many. All right, questions, concerns, comments? All right, so like I said, that last section that we discussed was mainly about terminology, making sure somebody say terms, you know what I mean by that, or degree, or what a polynomial is, and all the good stuff like that. So as always, try the stuff out, see if you get stuck. If you have any questions, we can address those. at the beginning of the next class, or you want to email me, you can always shoot me that email. Once again, as far as taking your test, when you're ready to take your test, jldavis@tcc.edu, and he will set you up with your test taking. You do not have to come into the school. And coming into the school is not even an option, of course, but they will set it up through Zoom and all the good stuff like that. All right. Questions? Yes, sir.
Can you get that password lock for me on my Connect Math?
Yeah, I'll take care of that. That's if you're talking about for the test review.
Yeah, for the review.
Yeah, I'll knock that out. Once I get out of here, I'll go
Okay.
in there and try to open it up. Make sure that that password is not on it.
Okay.
Yeah. All right. Anything else? Anybody else before we close out? All right. So you guys have a good one. Take care. I will see you on next class.
All right, Professor.
All right, sir. Oh, did I miss something in chat? Okay.